All right, well, if folks are ready, why don't we get going with this and see how it goes. Um, so we got a couple things on the agenda for this week. It was good to see some stuff get added. I snuck one in at the last minute to the top of the agenda to talk briefly about the upcoming 2.2.3 release, which we've started putting together. So, I mean, just touching that briefly as a quick update. So, as of yesterday, we opened a pull request with what we expect to be in that release. So it's I've linked it off the notes. This has been in test for a while now. And it's something we'd like to put out in the next week or two to get pulled together. So if you've got a chance to go take a look at it to make sure that we didn't miss anything, please do. If not, we'll pull that together and get that tagged and released as the next 2.2 release. That's mostly a lot of kernel compatibility stuff on the Linux side and some bug fixes and documentation. It's the patch deck looks big, but it's a lot of compatibility code for the most part, and then some bug fixes. But please take a look if you get a chance. And then
That includes the one Alexander Moten did for the sizing of the ZIL rights or whatever that was causing problems with BRT.
it does. So in
Okay.
fact, I'm glad you brought that up. So it includes, in fact, a bunch of changes that were BRT related fixes. So Andrew did a bunch of work there. We pulled in all of that work. So BRT is in much better shape. We haven't enabled it by default in that release yet. And we know we still have one outstanding BRT issue. We know we need to run down at least on the Linux side. So for the moment, it's still disabled. Hopefully we can run that down shortly and get that sorted out too. But so BRT will be at least in better shape in that release. Maybe to the point where people can experiment with it a little bit more. We think we'll have fixed everything if we can get that last issue run down.
Yeah, because when we had somebody write an article about it, and they ran into one of the bugs, but it turned out the bug was already fixed in master, and
Yeah.
in the 2.2.3 staging branch. It just wasn't in FreeBSD 14 yet.
Yeah, exactly. We want to pull all those together into the point release and start really kicking the tires there to make sure it's solid. But so yeah, BRT is in much better shape. Any other questions I could field about the upcoming release, or should we move on? Sounds like I'm moving on. So I see force pool export was next on the list. I don't know who added that.
I'm guessing the person who commented in the pull request, or somebody who saw the comment, asking where that was going. So that's something we're still working on. I think Don is actively investigating a case related to this, where the biggest problem seems to be the SPA namespace lock. If something is already wedged at, then forced export can't start to get in there and try to unwedge things. So we continue to work on that. It's not abandoned. It's just a little slow.
But progress is being made. Yeah, I mean, this would be a really great one to get over the finish line and pulled in once we're happy with it. It's been
Yes,
obviously
and I think we're in slightly better shape now that most newer Linux kernels actually have some concept of being able to force unmount a file system.
Yes.
Because when they didn't, it was a lot harder to make forced export work as well on Linux as it does on other platforms.
Yeah. And I'm sure you discovered the hard way. There's a lot of corner cases here, right? And just testing this
Yes.
and getting it right. And yeah, that's when I've looked at it,
Yes.
that's been the main
In
hang up.
particular, it's when the people using this run into a problem, it's different every time.
Yeah, exactly. And that's when you want it to work the most, right?
Yeah.
So it sounds like progress is being made there still.
Yes, it's just slower than we'd all like, but it is still moving.
Yeah, cool. So we'll keep an eye on that. Let's see. I lost my agenda here. Oh,
The
there it
next
is.
one was QEMU testing. I think, Tino, you were.
Yeah.
Yeah, that's me. Greetings to everyone from Germany. QEMU testing is a feature which would allow us to start a very strange list of operating systems with our custom tests. So I think it would be good to have, but I don't know if GitHub will actually allow us this extensive tests then because it will be a lot of CPU power, of course, and so on. I don't know if we have any limits on GitHub action runners. I don't know, but did someone already look into it in this pull request? We can have FreeBSD testing and so on, and current tests on systems like Debian and FreeBSD show a lot of errors. Our functional set, the full set is not okay on every system as it look like today. I can put a link into the chat so everyone can look at it.
Wait, so I understand right that you've got this mainly working at this point, but are
Yes.
seeing a significant amount of errors on the other platforms
Yes.
that we aren't seeing in our existing testing for whatever reason, maybe timing related or whatever.
Sorry. I didn't look exactly on the errors. Einmal Linux has some errors.
Yeah, the error is literally just one blank line. Doesn't seem to have any
No.
output. Just says error :
Or maybe I should share my screen. Would that be an option to show something?
The FreeBSD 13 one does actually have output. It was a 14 one that was just blank.
Yeah.
I mean, the 14 one looks like it has quite a lot of errors in addition to the summary possibly being blank.
The second time I loaded, it actually shows the errors. Line
Yeah, I
was
didn't get them
just
either.
blank. Yeah, but if I navigated away and navigated back, suddenly it's got a list.
Well, you know, GitHub is a small company.
See, it skipped a bunch too.
I would guess that something in the runner didn't set up the sharing stuff correctly, and it found something missing, but I'd have to go look at the logs. But
and then lots of ZFS send ones, or I guess that's redacted send.
um,
Well, redacted send is its own directory. What's rsend?
So with these tests, we see we have some problems. The QEMU, so the runners which are started here are just the plain install with a cloud init environment of Ubuntu, of Einmal Linux, of Fedora, and so on. And there the tests are don't run very smoothly. So we should take care with maybe this thing included, and the next time we should fix all these errors. It will be, I think, a good tool for getting the errors and fixing the errors, I think, with this pull request. The you have the bug list with dmessage and debug message. This is the complete list of only the failing stuff. And list of all tests is the list with everything.
A number of these, it seems like you canceled them early. Was that because they were failing somewhere, or?
Which one?
Just looking at the summary, it says that the CentOS Stream 8 one was manually canceled, as was the FreeBSD
I
15
can't
one.
see it. Yes, I was it. So they would have been run out of time within some later minutes. I think a half hour. I just wanted to test if the cancel is also handled very well.
Okay. This seems like a reasonable concept to me. Also, somewhat easier to iterate on than some of the lingering issues with the build bot being broken sometimes, I think.
Or just having the diversity of the two different ways of running, so when one of them's broken, the other one maybe still works.
Hopefully not. I guess my other question would be, did you look at all at running non-x86 things in QEMU for this?
Not currently very well. I wanted to make this thing first that it will run, and ARM and PowerPC. I have some runners, and I will try to make this also so easy to set up for us. The runners I have are a bit limited currently, and I have no real idea how I can implement this so that we can change the running system, which will be tested currently. There was too much administration in the background, and so we wanted simple, keep it stupid simple.
Yeah.
And this QEMU stuff, I don't know how correctly spell this in English, seems a good way to first test AMD 64, and later we can maybe emulate on GitHub runners, ARM or PowerPC, but of course I have also access to real hardware, which can maybe then also be used.
I think that the problem with using real hardware, unless we have substantial resources for it, is the same one it's always been, which is that if you have enough things that want to run, you will end up waiting forever on your tiny, unfortunate, or not even necessarily tiny if it's like a Talos 2 or something, but a big thing serializing all of the CI runs versus QEMU, for being much slower, does have the ability to scale on arbitrary hardware.
Yeah.
But the only other thing that immediately comes to mind for me about this is that it might be interesting and nice to explore using like native runners on what's it called, AWS, because they do offer ARM64, and I think we have an existing setup that if I recall, all the BuildBot stuff runs on AWS VMs.
Yeah, currently does. But I mean, I like this in particular. This is really cool because there's a lot of maintenance and overhead involved in running currently the BuildBot setup. So I find this pretty appealing. I mean, what gets backed by it? Like we could have maybe native runners on AWS still. I mean, export that kind of integration. That would be cool. But
I absolutely like it too. I was just thinking that if we already have an AWS setup, it seems like, well, that's all future conversation, as it were, right? Like,
yeah.
but
so it sounds like next steps here might be running down why we're seeing test failures. I mean, we do certainly have a never-ending list of small positives false positives we see, right? We just can't crush all down, but it would be interesting to run down these and see what failures we're seeing here.
I would bet that it's only a couple of cases of whack-a-mole in this case, but
Yeah.
I haven't actually looked
Yeah,
yet.
like it seems like a class break on the resumable send ones there. That it's just some little something missing, or maybe even just a
Probably.
utility or tool that the test depends on that's not declared properly or getting installed on the FreeBSD.
Sure.
Something.
My only other thought was the one that I think was already mentioned, which is I think there is eventually an upper limit on how much you can use GitHub runners for. I don't know that we're at risk of hitting it, but
yeah.
I suppose we'll find out.
Yeah. I looked into that briefly. I think they just throttle you. So we might run into the same problem basically for free projects where we can only run so many at a time, and then there's just a throughput limit we hit. This may be too much, right? Like we'll find out.
I'd be less worried about the para-virtualization of QEMU KVM versus actually virtualizing ARM or PPC on here, but I suppose we'll find out. I think they also may have a history of like donating credits for their big runners to open source projects, so we could also explore that if it becomes an issue, or if it doesn't, for that matter. But you know, I like this idea.
And we have big runners currently. It was a change on the GitHub runner system. I don't know, for 3 or 4 weeks, maybe. Maybe in the beginning of the year. I don't know when, but it looks like it's all AMD EPIC systems and 4 cores, 16 gigabyte of RAM, and very fast disks. Cool stuff.
I don't know that that's the same as them actually giving us larger runners, just that they might have scaled up the baseline.
Right.
Like, I believe they explicitly don't give you larger runners unless you ask for them, because they are much more resource intensive on how big the ceiling goes. I could be wrong, but that was my impression when I last looked into this.
They changed it. You can have now runners for private repositories also for without cost, but they are small. And for public runners, they all have bigger, better hardware now.
Yeah,
that changed 3
yeah.
weeks or so.
I was just talking about they have an explicit idea of even bigger runners that you cannot manually or you cannot run for free.
Okay.
So like if you have a paid plan with them, they have bigger runner options.
Okay. Of course.
Which I think you might be able to convince them to let you do. They might donate them to open source projects, was my impression, but I don't know. So that would be something to look into if we start hitting resource limits.
We have to find out.
Yeah. But no, this seems good, and I can talk to you afterward, and if you want help, run down why those tests are all failing. I was just offering to help you run down the test failures in that. That was all.
Yep. All right. Well, this looks great to me. I'm particularly excited about this since BuildBlock takes a lot of maintenance. I don't know that we'll be retiring it anytime soon. We'll have to see how this goes, but I'm excited about this personally. Being able to have more people, be able to add runners and maintain it and see all that infrastructure, it'll be good. All right. Anything else on that? All right. And Don, I think you're up. You found an
Okay.
issue with slow disk and MMP? I'm interested in this one too in particular because it's definitely something I've seen before and haven't run down.
Yeah, there's been rumors of it out in the field, and when I got assigned, I thought, oh, this would be easy to reproduce. Just Z inject some slow errors. So in this particular case, there's two players. The first one is the MMP player, and in MMP, there's a thread that will, on a regular cadence, update the Uber block so that a host trying to connect will like, oh, notice that and not try to import the pull. And what it'll do is it'll update the Uber block and then also check to see, did we do that in a timely fashion? And so that's pretty straightforward. And then so I had a pool with a lot of disk, made one of them super slow, and it's fine because what it does, that cadence is fast enough that the slow guy just effectively gets ignored. And his ZIO done, he's like updating the clock, but the clock's been updated way, multiple times by other people. So that won't suspend your pull. So I thought, well, this is a tough one. It's like, what's really going on? So I think it was Alan that suggested that, hey, let's throw some errors in there as well. So that if you have injectors for errors and delays, then you trip it. And so this is where the other player comes in, and that's the VDEV probe mechanism. So there's this mechanism called VDEV probe, which will go and read and write the pad parts of the label. Safe to write there because it's like not in use. And it issues 3 reads and 3 writes. And if one of the reads succeeds and one of the writes succeeds, then it says, the VDEV is still okay. Basically, if you can't read or you can't write to any of those, then it'll say, we're bad and fault the pool. So
well, the disk, right? Not the pool.
Oh, yeah, sorry, the disk. Yeah, it'll fault the disk. So if you have redundancy, that's usually not a problem. So what happens is at the end of a ZIO done for a VDEV, a leaf VDEV, it'll actually say, hey, go probe this guy. I got an unexpected error. And that makes sense. It goes and does. And so what it actually does today is the VDEV probe function itself issues those IOs. And then in addition, if it's being called from the ZIO done layer, it schedules a future VDEV probe through a async, SPA async mechanism. And it kind of ignores those first IOs that it did, which is kind of strange, except that if you can't read and write, then it'll throw a Z event. So it'll throw a Z event error like, hey, the probe didn't work, but it didn't take any action on that. But then in the future, in the SPA async mechanism, it actually will go and do a VDEV reopen, which will tear down the VDEV, open it up, and as a side effect of open, it actually does another probe, same probe routine. That's some semi reentrant, and then that probe routine, it actually looks at the results in the VDEV open and says, oh, you got back an error, not configured in this case, and then it faults the VDEV. The problem is that in that async task, it takes a global writer, SPA config writer lock, and then it goes and then does all these IOs. And if they happen to be slow IOs, which they are in my test case, then you just take a long time holding that writer lock. Meanwhile, the MMP thread I mentioned earlier is like, hey, I need to take the lock as a reader real quick so I can pick the leaf VDEV that I want to write to. And so he just gets stuck. And so his cadence is broken. He's not doing anything for tens of seconds. And then he finally gets back and he says, hey, we overshot our budget, and suspends the pull. So it's like, so there's kind of 2 issues. One is on the MMP side, he's fragile in that he's like, he has no guarantee that he can get the reader lock in a timely fashion. That's probably a second issue that we could tackle down the road. But to solve this problem, what I did is I re-looked at that, why are we doing double probes? It's like, so I changed it to be, when the ZIO induced probe in the IO done, when we're firing off the Z event, hey, just schedule an async task to degrade the VDEV, to fault VDEV. And so that mechanism works. You get the VDEV faulted, it doesn't interfere with the mechanics of that. And it also frees up the MMP thread to keep making progress. So my sort of question is why I brought it up here is that thing goes way back. I mean, it was circa 2008, maybe 2007. And, you know, it was like Bill Moore and you know, people, you know, it's like it's been there forever like this, and as far as I can tell. So I don't know if there's any benefit from doing a VDEV reopen as part of that probe mechanism, other than it looks like they wanted to be able to do it in the right context. You know, you need to have the right context to be able to change the VDEV state. And so that's my only guess, but it does a lot of things. You know, it has to read the label, revalidate everything. But, you know, if it's essentially just a probe to say, can I do IO? Then it's not necessary to tear it all down and take locks and do all this stuff. It seems like, and in the context, you have a suspect disk. So let's hold this global lock and do, you know, IOs to it. That seems kind of, you know, questionable. Like you're going to get into trouble there. And I think we do. So, I mean, MMP is the first victim. There may be other issues where we're, you know, we're causing performance problems or whatever by holding that lock for, you know, an indeterminate amount of time. It's like the drives can be really slow. So in my case, I think I was injecting 5 seconds, you know, those, you know, 6 IOs, you know, it was adding up to 20, 30 seconds. So anybody have any insight onto why it did a VDEV reopen instead of just doing the simple probe? Was it just leveraging?
Reopen was just used as a convenience because
Okay.
VDEV Open had it, so I think that's why it was there. And I think what the intent of it is that you may get an IO error during a normal write, and yet the disk itself isn't faulted, right? So that's why it's like, okay, let me go read the label regions, because I may have just like been writing to an area and that area was bad, you know, maybe there's a bad block there, so I got some error back from that, but yet the disk itself isn't totally bad. I think this dates back to the days where we were dealing with like Seagate drives that had like firmware errors, and so you could end up faulting all your disks very quickly if you didn't probe them, because you would just get these random errors, and then next thing you know, your pool suspended because you just simply faulted them as a result of an IO error, and you'd suspend. So that's why the probe logic is kind of the way it is, where it's like trying to validate that in fact the disk really is bad. And I think the reopen logic was just used as a mechanism because the probe was already in, you know, when we do an open, when we start the pool, it's like validate that you can do something to the disks. So the reopen logic was just as a mechanism to, like, you know, use it without adding more plumbing.
Yeah, that was my take. And so this way, we do the VDEV probe. Yeah, and I actually saw the two events, right? You get one from the initial probe, and then from the VDEV reopen, which is scheduled in the future, you get a second one. So you get 2 probe events. So it's like both mechanisms work. So my solution would just be to do the probe like it does right now, and in the IO done there, if it does think that, hey, I can't even write to this thing, then it can schedule a async task to go change the state.
That seems a lot better than having to take the lock and causing all these problems.
Yeah, that's just like a long time to hold that. And I think, yeah, that predates MMP, you know, which is
Right. Well, I
dependent
think
on
it
that.
even
Nobody holding that
predates-
thing forever, you know.
I think it also predates the ability to have the async SPA tasks as well, right?
Yeah, that came in with, well, we started using it with like remove and other things like
Mhm.
that. But yeah. And then this is sort of independent from the fault management layer, which will like make a determination based on how many rates of errors you're getting in a set amount of time. But they don't compete. They're just two different ways of determining that the disk is bad. Anyway, I opened a PR, so if people want to go look at that, it's pretty straightforward. And then I added a test, and the test would fail every time. And then so it's problematic because if you suspend a pool from MMP, you're not allowed to clear it. And so that's not good for your test suite. So I added like a little workaround, like, yeah, if it's a tiny pool and it's, has test in its name, we'll allow you to clear it, so that we don't, the test suite doesn't just die. But pretty straightforward. People can look at that, and I'm happy with the results. Seems to solve the immediate problem. We may want to go back and look at the MMP side to have better guarantees there, but this was the bigger obstacle in that path.
I guess the other thing is should the MMP only count the time after it got the lock to how long the IO took, instead of including all the time it spent waiting to get the reader lock to be able to figure out which VDEV it wanted to write to. So it wouldn't think it exceeded its time quota because of the disk, but instead because of, but I guess that time quota is about the other system reading it, so you don't want to do that.
Yeah, exactly. That's kind of a hard time limit, right? We can't really mess with.
Yeah, because if another host imports you during this time you're really kind of asleep, you don't know. We don't go back and say, are other people writing us? It's like, so it would be bad.
One outstanding bit of MMP work, though, that's worth looking into maybe would be the ability to resume the pool again. So in the initial version of that, we kind of said, oh, let's play it safe and suspend the pool and make it so you can't possibly resume it just to be super safe, right? But, you can imagine schemes where you could like renegotiate if you could safely access the pool again so you could resume it. The deferred work, right?
One of the things we were looking at is, can we allow a forced export of the suspended pool and then just import it without having to reboot? Because at least that way you're safely getting rid of any in-memory state that might actually not have made it to disk or whatever. Because trying to resume with, you're not 100% sure what made it to disk and what didn't is,
Yeah, I think you'd want to, if you're going to clear it, you're going to want to have to revalidate that no one else is writing to it. So you kind of really want to tear it, like export, drop everything and export it, and then re-import it if you can. But
so I think we will maybe be able to pick that up as part of the forced export work.
That would be great.
That specific case is, maybe actually an easier one for forced export, since it's less likely things are terribly broken compared to the other cases where you're trying to force export something.
Yeah, and we're finding that we have customers who have multiple pools in an HA setting, so it's like kind of forces their hands, like, you have to reboot. There's no other out here.
I mean, we have logic at import time to do that whole little MMP dance where it checks if the pool's active or not on another host. So you could probably leverage something like that to decide if it's safe to import the pool, maybe. It would probably take a lot of thought to convince ourselves it was actually totally safe, but it's probably doable, it seems like.
I mean, my understanding is the MMP logic is never totally safe anyway. It's just we are more confident now than we would have been without it that it was okay.
It should actually be safe as long as you can read from the disk. So there's like that state gets written to the disk, so both hosts have that information for how long it's safe to wait before they actually import the pool. So markers are left on disk to control that time interval. So it should be totally safe, but obviously you don't want to get it wrong. So it's good to err on the side of caution here. But yeah, it's shouldn't be your only mechanism, I suppose.
Sure, I was just thinking that if you have the MMP value set differently on both sides, then your life is sad, I think. because that's not a pool property, I don't believe.
But I think Brian said it's
Yeah.
one of the things written to the Uber block, right?
Yeah, it's stored on the labels on disk. So it doesn't trust the pool properties or anything. It like reads that information out of the labels on disk during the import, and it stores there what the settings were, so you can't get them inconsistent. And then it also stores like what the latency was when the writes were happening. So you gotta get an idea of like how bad was it? How long do I really have to wait in the worst case here before I'm guaranteed that the other guy will have suspended the pool?
Interesting. I didn't know that. Thank you.
So where things get a little dicey there is if you allow the other guy to resume the pool, that's where it gets a little bit thornier, right? But
Yeah, whereas if we make you export it and re-import it, then you're as if you were the other node, you're just making sure
Yeah.
nobody else has touched it in the time interval that was promised.
yeah, and that maybe gets you 90% of what you want anyway, which is the ability not to reboot the pool or not to root the host, right?
Yes, especially if you have 5 pools and one of them gets suspended, it'd be nice to have a way to get it back without interrupting the other 4.
Yeah.
I think we have one more item, but first, Don, is there, since George is here too, any more to say about the concurrent pool import?
Well, I think we got some good testing in there. George, I updated the injector. You had made a comment on that pull request.
Yeah,
And
I looked at it. There's just a couple like style things that we need to fix, but I think we can merge it once that's there. I'm getting ready to like restart my testing with more pools, but I think you guys have been doing stuff with. Has this actually been used at the customer, or you still doing internal testing?
I've been doing it my own local testing. I'm about to do it on a customer system now. So I was waiting for access, but now I have it now. So I'll have results this week, George.
Okay. Yeah. I think once we kind of go through that test, we should be able to post the PR.
Cool. Yeah, I think this is the beginning of a journey of unentangling the spontaneous space lock. For other, export would be the next, I think, candidate. But
Yeah, I think that the next one we're looking at is export, and then also we talked about previously async free of the arc. It looks like somebody else saw the video last month and pointed at that somebody else's public ZFS repo has the start of something for that. I don't know if it was Nexenta or Nutanix or somebody, but
I think it was Nutanix because they pinged me too.
Okay.
And they said they were going to update the PR, but I don't know if that's been done.
Okay.
Right. Looks like we got another entry on the list. Rich.
Yep.
Oh yeah, this is your part 9 question.
Yeah. I recently ran into
part 9?
On thanks, FreeBSD developer. But on Linux, much like how Solaris used to do this, if you create a whole disk in ZFS, it partitions the disk with GPT, and it carves off almost all the disk in one partition, and then it creates a 16,384 sector long partition at the end that serves very little purpose. And
I think in Solaris that is for the EFI system partition.
That would be too small for that. I think that was for the VTOC partition.
Okay.
According to someone I was debating this with.
I know in
on
Illumos
Spark
they've
systems.
added a pool property to let you control the size of that partition so that you could make it big enough to be an ESP.
That would make sense. But I specifically recently ran into the fact that on FreeBSD, when FreeBSD labels things as whole disk it means it. And this confuses the expand logic very badly on Linux.
Yes.
It silently errors if you try to online a disk.
Oh.
It does not succeed, but it does not print anything. It just returns 1. I have a peer to fix that, but that's not the main point of the conversation. So my question became like, is there a reason we still need to do this? Because this seems like another difference between FreeBSD and Linux where there's not really a concrete upside on Linux. Like you can always make your own partition table and that's fine. But, you know, for the case of we hand it the whole disk, if we don't have a concrete reason to keep doing this that I found, should we keep doing this? This also caused another issue, which I need to go try and open a PR for, because like I said, it's 16,384 sectors. And so if you have 512E disks and 4K native disks in the pool, you cannot replace a 512E disk with a 4K native disk if it's whole disk, because it will create too large a partition on the end. And then it will say the
different size
result is
partition,
too
yeah.
small. Yeah, because it's sectors, not size. So, you know, that is a very confusing experience when you know the disks are the same length, but so that seems like a bunch of complexity, and I haven't found anyone who could give me a concrete reason to keep doing this. I'm open to it if there is one, but I haven't found one.
Yeah, so we're doing it initially just for legacy reasons, right? Just because it was done on Solaris. So it was implemented on Linux to make the pools look the same. And then we brought that forward all this time. I think the only good reason I know you've already stumbled into, which is like the Linux expand logic depends on there being a partition there at the end. I believe it checks for it, right? And if
It does, and
yeah.
it gets very confused if there's not one.
Yeah, because it expects there to be one.
Yeah.
Right. So it keys off of that to know whether it's safe that it's a ZFS disk and that it's, you know, how far it's safe to expand.
Yeah.
It doesn't have to work that way, I don't think. But it currently does.
Yeah.
I think I think the expand logic at the moment, right? It verifies that there's a part 9 at the end. And then it like recreates the partition tables, move that part 9 to the very end of the disk, and then expands into whatever space is left there. So it's kind of a safety check, I guess, in some sense. I don't think it's required we could rework that logic.
Yeah.
If we didn't have that, how would it just like if you expanded a device, is it just like, hey, you can start writing at the end? Is it smart enough to know that? Like, what does it do on FreeBSD?
Yeah, I think it calls the kernel and says how big is the disk again, and it gets a new
And then
bigger
just
value
updates
and,
like all
and then
our A
updates.
sizes and like,
Yeah, allocates the additional meta slabs or whatever.
yeah. I mean, that would be great. Like it
Yeah,
would be nice to get to
two
do that.
minds
I
on
just
this
don't know
one.
how we would migrate existing pools to that. Like,
I mean, migrating existing pools isn't that hard conceptually, right? Like, because there's two things, right? If the leaf VDEV isn't marked whole disk, I think it won't try to expand it. It'll just do the thing FreeBSD does, where it just rereads the size and goes, great. So like online expanding to a larger partition size is, I think, not the hard part here. And if we already have existing logic we're relying on to check if we can expand it, then we could just expand it and not put the tail end on it and rely on not doing that if we don't have the device labeled as whole disk in the first place, which I believe is what it already does. Like, I don't think it will try to do that if the disk is not labeled that, which is where the FreeBSD issue came from, because FreeBSD, actually, the disks I saw, I think, had 2 partitions, but not the way that Linux does it. And I think it was like partition 2 was the rest of the disk. But anyway,
That would have been manually created by the installer or something, not by ZFS.
But it was labeled as whole disk, which is what made it fascinating. Because I don't think you can manually set that
No.
without custom tooling. So it got confused because I believe it checked for that first, or else it wouldn't have triggered this logic. Otherwise, it would have just reread the disk and checked for more space rather. So that was how I got to this point, was things created on FreeBSD that were then imported on Linux and then had a weird issue where they offlined it, and then trying to online it got confused.
So like this is literally online, not just online-e to actually cause the
Yes,
expansion to happen.
actual
Okay.
online fails at this, even if you don't use -e first. Because I don't remember exactly why the logic fails that way, but it does. And I found that fascinating. But
If so, if we didn't have this, I'm assuming that like one of the other big benefits that I would see is, if this is true, is that it's less interaction with UDEV. Because today, like when you expand, it has to like remove the links, recreate the links, and that dance between like, are the links there, like all that stuff could go away, I'm assuming.
I don't think so, because I think you'd still want an actual partition, just not two of them, right?
Right,
Like,
but it doesn't have to go like it when you resize it. Does it have to go recreate that partition link, or would it be just like, hey, you already have like part one or whatever?
I think it would, because if I recall how Linux's logic works correctly, you end up basically needing to reopen the device before it will rescan the partition label. So, like, there can't be anything currently holding open the old disk before it will rescan the disk to see the new size. So I
Right, but
think
you would resize that one partition rather than have to delete and create the part 9 at the end, and so maybe UDEV wouldn't actually have to see the link go away and come back.
maybe, but it depends on whether you're holding it open through that link in the first place.
Mm-hmm.
That was what I was thinking, was that I think you still need to do a reopen to trigger that, and I don't know. It might reduce the amount of dancing you're doing there, but I don't know by how much. And you'd still need to keep the old logic around for migrating old disks, right? And it still needs some refinement for the edge case that I ran into that is the whole conversation starter. But conceptually, I couldn't find anyone who could find a good reason to keep it. And it confuses a lot of people that I then have to explain, no, it's fine. Don't worry about it. Don't.
Like in the past, I've talked about FreeBSD going more the way that Linux does. Mostly that was predicated on using the second partition for boot code, and meaning that way, when fault management, automatically replaced the disk, ZFS would recreate the right partitions and maybe populate the boot code. And none of that exists today. And so if it's already got to be managed externally, then it may make more sense to get BSD and Linux doing the same thing on the simpler thing rather than the more complicated one.
Yeah. That also seems a little weird to try and special case into ZFS in the first place, right? Like,
well, it's just like Illumos did. It's just a pool property on how much space to reserve for not ZFS on the disk.
No, absolutely. I meant on the concept of trying to then fill it in if you replace the disk. Right. I don't disagree with it in terms of practicality, but like theoretically, it seems like a weird thing to put in ZFS and not some other layer. If ZFS isn't, if it's not,
right, it's mostly about
when
ZFS is creating its label, if it's going to create the partitions for me, that's helpful. But yeah, like
you can
saying,
do that. Like,
to do the other bits, it makes more sense for it to be outside of ZFS anyway, in which case ZFS could be doing the easier thing.
Yeah.
So looks like Alexander might have had a thought. He made a face.
I had a thought that I would like to get rid of the noise. If you look in, by ID, there's actually like 3 names now. There's a WWN, the SCSI name, and some other weird name. And so that's like 3 times, N drives, that someone has to open, read. Oh, it's too small, and so it's like it just creates a lot of noise to have these sort of empty partitions in that namespace.
Yeah. It might also be an interesting thing in terms of consistency to have one place that you might expose a more definitive name rather than the exhaustive listing in by ID, because then people get very confused when they replace a disk or import the pool and they get a WWN for 3 of the drives, an ATA name for another one, you know, but that is a nice improvement, but not necessarily.
Yeah, Tony, here's your chance to plug by VDev.
By VDev has problems with using it for that.
Yeah.
On Tronas, we traditionally create GPT partition and use GPT label IDs just to not depend on anything from underneath, on device names, on transport. Many RAIDs tend to hide disk identification, so those are unreliable, and we find GPT ID the most reliable. But since FreeBSD, we never trust ZFS to do partitioning. Even with Tronas scale on Linux, we always partition ourselves. So we don't have interest particularly in auto partitioning, would prefer to more simple way. And it's a bit confusing how that whole disk flag is set between FreeBSD and Linux. I remember there was some inconsistencies in how that flag is set and behaves when you migrate between FreeBSD and Linux. I don't remember details right now, but it was a mess. So I would be happy to remove it altogether. I can recall only one case when full disk replacement was used on FreeBSD. That was done by Spectral Logic to allow replacement by physical device slot. You just remove one disk, insert another one, ZFS picks it up and go. But it doesn't partition disks. It always uses raw disks. Since FreeBSD doesn't partition disk by itself, and that seems to be simple and straight. But only question how to migrate Linux to go that way. I would be happy if it would.
I don't think it's that big a deal to migrate, right? Like we already have to delete the partition and put it back later. So we could keep the logic for deleting it, but not the part that puts it back.
No, it's mostly about, I was thinking about using in one pool disks from both times. So they will have slightly different sizes, and there could be some other artifacts based on that.
Yeah, but I mean, the partition is going to be either 8 or 64 megs, which should be smaller than I think we will almost ever carve up a Metaslab to hold. So it should just be noise, I think. Like it shouldn't result in practical size differences, and otherwise I think the expand logic will just do the right thing and grow it if we're not trying to partition on the end of it afterward. If you do an online manually with expand or auto expand, either way. And there's already existing problems in it. Since it's based on number of sectors, not size. So you can already run into bad problems with trying to replace a disk with the same size and a different physical sector size, and bad things happen.
Maybe at very least we could change the logic to physical size and to make it more predictable. I wonder in the time when the code was implemented, was anybody cared about different sector sizes? Maybe those weren't really existing at that time.
Mm-hmm.
Probably
and maybe
not.
they really mean 8 megabytes, not 16,000 sectors.
So... I would strongly suspect so. I mean, it's empty, so it doesn't really matter how big it is. But then you have a question of migrating the existing ones too, right?
Yeah.
I don't think it will cause that much of a problem. I think almost anything will be an improvement from you try offlining a disk and it online silently fails, which is what it currently can do. That was a fun debugging step. But the only other tail question is, does anyone know of anything that depends on offline or online never printing an error? Because there are a lot of cases where it currently doesn't. I don't think anyone should be depending on that, but...
Yeah. Do you know if it at least logs an error code? Does it at least like
it returns
fails?
1 but does not print anything, which is the same versus returning 0 and not printing anything, which is what it does when you online successfully. So you can see how this was slightly exciting to investigate. It does have some cases where it prints errors, just not this one. So I don't think anyone should depend on that. It's just the only thing I could think of without extending it and going, print an error every time this fails. There's also some mild complication where one of the functions doesn't actually return errors, but that's fixable. But okay. If nobody has a reason really to keep it, then I'll probably go try implementing a PR and get feedback on it.
You're just looking at getting rid of partition 9 here, right? Not
Yeah.
necessarily all partitioning, right? So that
No,
would still be different than FreeBSD's default behavior, right? It
Um,
doesn't create any partition tables, right, by default?
Correct.
Yeah.
really? That's
Generally never. There's no even code for that. It's not even by default or not.
Right.
Just
Well,
not
even
there.
getting rid of 9 doesn't really make them behave the same quite yet.
no. But I thought that part of the reason to have partition tables on it in the first place was that it's not. Otherwise, things that have no idea what they're looking at don't necessarily may read data and have unexpected conclusions.
Yes, that's what FreeBSD used to call dangerously dedicated mode, because if you booted Windows 95, it would be like, hey, that disk isn't partitioned. Would you like me to format it for you?
Windows 11 still does that, just so you know.
Yeah, from that perspective, having partition table just would be safer to say there is something for systems that don't know about ZFS, but still auto partitioning. Maybe we could look how, like, if we are replacing a pool already have partitions and try to follow same logic, or because it would be less predictable.
Yeah,
more compatible. I don't know.
Yeah, this was both in terms of this was both me trying to reduce the complexity and surprising outcomes and going, why is this? And also my slow drive to go, why are FreeBSD and Linux different? In ways that possibly nobody but me cares about. But yeah.
In Solaris, if I remember correctly, there was one more difference. There something about caching, write caching enabled for raw devices versus partitioning.
Yes.
Something wasn't cached there that they required partitioning for some performance reasons. But for FreeBSD, it was a knob. For FreeBSD, from the FS performance, partition and disks are exactly the same. It doesn't differentiate. It's geom provider one way or another.
Right. Whereas on Solaris, it was if it's a partition, then the caching is disabled, I think. Is what it was.
It's weirder than that because Solaris had to have write caching off if UFS was anywhere on the drive. So it was that it enabled the write cache if it had the whole disk. Is my recollection of what this logic existed, was that it was by default off because if UFS was anywhere on the disk, you could not do that.
Right, correct.
Of course, every other operating system does not have that caveat, but okay.
For that first primary partition too, it's also a little different than the Solaris code in that we make sure we align it to a 1 megabyte boundary at the beginning. Just where it starts in, because we found that if you want to run ZFS in a non-recommended setup on RAID arrays or something like that, not having it aligned can really trash your performance. So if you're running something under ZFS, it does help to like align it to that first megabyte.
Yeah, but changing it now again could change VDF sizes and create problems with migrations that should be considered.
Right.
Conveniently, if we are already aligning it to the first meg and we have padding on the end, we do have flexibility. So that could be one reason, but fortunately we are mostly past the era where disks that say 250 gigs mean 5 things. So okay, yeah, I have run us past, I think.
It sounds like where we'd really like to get to is having like FreeBSD and Linux have the same partition layout by default, right? It would be nicer to do the same thing.
I mean, conceptually, but in practice, that would mean we'd have to convince FreeBSD to have partitions on the layout by default,
Yeah.
which may be a hard sell, or maybe not. I don't know.
No, many people, I bet, have partitions. As I've told, on Trunas, we do create partitions just for purposes of GPT IDs. We don't boot from data disks on Trunas, but we still partition them. And right now we just create partition for full disk, just align it to 4K, if I remember correctly, not for meg, but at least more or less difference would be limited to specifics of partitioning tools, how much space is reserved for partition tables, but at least extra partition should probably be removed. Or maybe a few steps first need to be ignored and then remove it, or something like that, so that it could be backported to earlier branches to reduce troubles.
Okay. So it sounds like at least for the next step, we're all on the same page about this being okay to do. Then
Yeah, at least looking into it and opening a PR and seeing what the consequences really are.
exactly. What could go wrong? But
I mean,
no,
it still might be a bad idea, right?
yeah, exactly. But I'll open a PR probably in the next day or two with the more erroring, because that was very helpful. And then I'll look into this more after that.
Great.
Can I have one more quick question? It's after an hour, but still. I've tried to bring the topic on a Slack channel, but haven't seen any much responses. Can we put some sort of plans, or more or less strict, about next release time frame 2.3? I'm asking from perspective of next Trunas branch, which we plan to do in autumn. And I would be happy to switch that branch into ZFS master from perspective of early testing. I brought a topic 1 or 2 months ago that we don't have early testers on Linux almost completely.
Yeah.
So FreeBSD main appears to be most users, even more than Linux. But I could switch Trunas master into ZFS master if there would be promise that by the autumn we'll get it branched and on the way to release. Otherwise, I end up in weird situation.
Yeah. So when would we need to branch it to get it into, TrueNAS as a release? Would it be, you're saying autumn time frame? We would need to create a branch, or we need to have a release?
A release time frame is scheduled to be, we go into 2 per year, April, 1 October. So by October would be good to have a release, or at least something close to release. I was thinking if 2.2 we release it end of Q2, if we do 2.3 again end of Q2 and kind of stay with that, it would fit us.
Yeah, I mean, it's hard to commit to that kind of stuff. There's features we want to get in there, but yeah, we could just cut a release with whatever we've got at that time for 2, 3.
No, like more or less like months or 2, but just at least not drag it indefinitely without any time frame. So end of Q2 would work for us, and any schedule we could adapt. But if there's no schedules, then we can't use master since we don't know when it will stabilize.
Yeah,
we need it to be stabilized by some known time.
Yeah, that doesn't sound unreasonable to me. I'd like to get a shorter cadence too between some of these major releases to get some of those features out there, right? We just merged things like RAID Z expansion, right? Which are great, but not an tag release. It'd be nice to get that out there in a more reasonable time frame than some of the last releases which have drug out.
No, I'm not exactly shorter, but I think it was told that it should be 1 release per year. Last time I looked, we branched end of June last time. So if we would again branch end of June, that would be once a year. Just 2.2 we delayed for 18 months instead of 12. So if we could commit to 12, I would be happy.
Yeah. Why don't we talk about it more? But I don't think that's unreasonable. Like shooting for end of June sounds reasonable to branch. And hopefully we can wrap up some of the major features. The ones that are on my short list to get in are, we just talked about it earlier. The forced pool export work would be great to get in. I think, as with the direct IO work. I don't know if there's other things on your list that you guys are working on that you'd really like to make sure get into 3.
Not as directly, but Alan's company is working on dedupe rework, and I made a review for that code. So there's another iteration of changes based on my review, and hope after that, in a month or 2, we'll get it published, and hopefully sooner rather than later. And it should be again ready by June, hopefully.
Okay.
So that would be interesting.
Just one question. The version that you saw, does that have any migration for existing dedupe users?
There's no migration, but they can coexist happily in parallel. The existing pool will work as they are, but if you switch dedupe algorithm, new algorithm will use different dedupe table, while previous will gradually decay.
Okay, so there's no migration, but this standard new data gets written to, yeah, okay.
All right, well, we're a little bit over. I mean, if folks don't have anything else, we should probably wrap it up. Sounds good. All right, well, thank you everybody for coming.
Thank you. Bye.